So till now we have discussed the various other properties of electric charge, such as additivity of electric charge, which means if you have two charges, for example plus E and plus 2E, then you can add those two charges and it becomes plus 3E charge. That is, you can add charges whether negative or positive. For example, if you have a negative charge minus E and a positive charge plus E, then the result is always going to be 0. That is, the body is neutral. Okay, and then conservation of electric charge, which says just like your conservation of energy, that is, energy neither can be created nor destroyed, same is in the case of charges as well. Charges neither can be created nor destroyed, first thing. Second thing, for example, when you consider a charged body, okay, if this is positively charged, this is a rod that is positively charged, and this is a piece of cloth, suppose this is negatively charged. Okay, after rubbing the cloth with this particular rod, it becomes negatively charged and this becomes positively charged. But when you take this as one system, one isolated system, then the charge is always conserved. That is, before rubbing this cloth with this particular rod, the rod was neutral and the cloth was also neutral. But after rubbing this rod along with this cloth, this lost some electrons, whereas this cloth gained some electrons. Hence, this become negatively charged and this become positively charged. But when you bring this to close, again it becomes neutral. That is, charge in an isolated system is always conserved. And then quantization of electric charge. We had discussed this previously, that a charge is never continuous. For example, if you take the example of stairs, this is 1, this is 2, this is 3, this is 4. Now when you walk through the stairs, you will put your step here, here, here and here. You do not put your step somewhere here. It is not allowed. Same like the case of a stairs is the case of charges. They are quantized. That is, you can have a charge of Q, you can have a charge of 2Q, you can have a charge of 3Q, but you cannot have a charge of 1.2Q or 2.2Q. This is not allowed because charges are discrete, they are quantized, they are not continuous. And then charge is a scalar quantity. This is very, very important with respect to your exam purpose, because multiple choice questions has been asked regarding charges. Are they scalar or vector? Charges do not have direction. For example, the symbol of a charge is Q. You do not put this arrowhead over Q. This is not allowed. Okay, if you put an arrowhead like this, that is the symbol of a vector, it's wrong, because charges do not have directions. And then this is the most important thing in the properties of charges, that is, like charges repel each other, whereas unlike charges attract each other. In this case, this red ones are the symbol of a positive charge, the blue ones are the symbol of a negative charge. If I have like charges, for example, one positive charge and one positive charge, what they do, when you bring these two positive charges close to each other, they are going to repel each other. Okay, it's like they are very good enemies among each other. So when you try to bring them as close as possible, they will always try to go apart. Same is the case with a negative charge. A negative charge, they are like charges, both charges are negative, hence when you bring them closer, they repel each other. Okay, so like charges repel each other. And then unlike charges, that is, if you bring a positive charge and a negative charge close to each other, they tend to attract each other. Okay, they'll attract each other, and this is the reason why we call as why we say that unlike charges attract each other, whereas like charges repel each other.
Take this particular example where in the left hand side there is negative charge and in the right hand side there are two positive charges. So when you keep them close to each other, they tend to move away from each other, that is they are repelling each other. And then take this particular example where you have a negative charge and a positive charge. When you try to keep them at a particular distance, then they tend to attract each other.
So these are the properties of charges that you have to know, also understand, because if you do not understand the properties of charges, what charges do and how they behave and what is the principle, are they conserved or not, so if you do not know all these things, the basic things, then you might face a little bit of problem later on with the as we go on with this particular theory of electrostatic. Okay, so please try to understand the basic properties of charges, and from here on we start with the Coulomb's law.